For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@solidworksassignmenthelp.com or reach us at https://www.solidworksassignmenthelp.com. Problem 1. A simply supported rectangular plate is subjected to a uniaxial compressive load N, as shown in the sketch below. A. Calculate and compare buckling coefficients corresponding to the four first buckling modes as a function of OB. B. Discuss the result for the specific value, A/B equals square root 6. Problem 1 solution. A. Calculate and plot the buckling coefficients corresponding to the four first buckling modes as a function of OB/KC equals M, B/A, plus 1/M, A/B, to solidworksassignmenthelp.com. B. For A/B equals square root 6 KC equals M/square root 6 plus square root 6/M, 2. M1234 KC 8.174.174.175.04. Problem 2. AH equals 10 mm thick elastic flat bar stiffener is welded to a plate at the bottom. solidworksassignmenthelp.com. A. State the boundary conditions around all four edges. B. Calculate the total buckling load PCNCB of the stiffener, assuming that A equals 1000 mm and B equals 200 mm. Hint, use the graphical solution fork in the notes. C. Determine the length of the buckling half wave. D. How much will the buckling load change if the boundary conditions at the loaded edges are changed from simply supported to clamped support? Problem 2 solution. A. Boundary condition for the unloaded edges are solidworksassignmenthelp.com. At the bottom, clamped boundary condition W, x0, equals 0 W, x0, equals 0 at the top, free boundary condition W, xb, equals 0. W, xb, equals 0 in addition, if loaded edges are clamped W, 0 Y, equals W, A Y, equals 0 W, 0 Y, equals W, A Y, equals 0 simply supported W, 0 Y, equals W, A Y, equals 0 W, 0 Y, equals W, A Y, equals 0. At the bottom, clamped boundary condition W, x0, equals 0 W, x0, equals 0. B. Calculate the total buckling load. solidworksassignmenthelp.com. PC equals NCB. A equals 1000 mm. B equals 200 mm. Using the buckling coefficient chart on page 12. solidworksassignmenthelp.com. We are considering case D, A/B equals 5. Notice that the cases for the loaded edges being clamped and simply supported are almost overlapping in buckling coefficients. KC equals 1.3. C. Determine the length of the buckling half wave. If edges are simply supported, from the plot in part B, we can see that there are 3 waves in the M direction. Wavelength is equal to the length of on side divided by the number of waves in that direction. Lambda equals A/M equals 1000 divided by 3 is equal to 333. If edges are clamped, it is difficult to read from the chart about how many waves M exists. solidworksassignmenthelp.com. D. As noted in part B, the buckling coefficient for simply supported edges versus clamped loaded edges is approximately the same. Thus the effect on the buckling load is insignificant if the boundary condition change from simply supported to clamped support. Problem 3. A relatively short rectangular prismatic box column B1 is subjected to a uniform axial compression. Take B1 equals 40 mm, B2 equals 60 mm, H equals 1 mm. Then beam is made of an aluminum alloy with yield stress of 300 MPa. A. Calculate the total buckling load of the column. B. Consider a square column of the same cross-sectional perimeter. Which column is stronger, square or rectangular? C. Plot the load, shorting relation for that column consisting pre-buckling phase and post-buckling phase. Bonus. Consider a rectangular prismatic box column of the same cross-sectional perimeter. Which column is stronger, square or rectangular? Solidworks assignmenthelp.com. Problem 3 solution. A. Calculate the total buckling load using the derivation in lecture note page 17. In our case, use the plot in lecture note, see next page, when B1 equals B2, Kc equals 4.1. Solidworks assignmenthelp.com. For aluminum alloy. Buckling stress. This is elastic buckling. Solidworks assignmenthelp.com. B. Crippling load of the column use derivation in page 2 of lecture notes 16 where in our case. C. We know that in post-buckling phase, Young's modulus reduces to half of the pre-buckling phase. Solidworks assignmenthelp.com. In a half-wave length B, for pre-buckling phase, where EPRA equals 69 GPa, H equals 1 mm. For post-buckling phase. Solidworks assignmenthelp.com. Bonus. For a rectangular prismatic box, assume B1 equals 48 mm, B2 equals 32 mm. So that B2/B1 equals 0.67, using the plot Kc equals 5H1 equals H2 equals H3. Compare with square prismatic box column. Square prismatic box column is stronger. Solidworks assignmenthelp.com. Problem 4. Buckling of a box section. A relatively slender, thin-walled square box column is subjected to AL compression. The column is simply supported at its ends. What is the combination of the geometrical parameters, length L, wall thickness H and width of the fledge B, so that the critical Euler buckling load will be equal to the critical local plate buckling load? Explain all the assumptions that you made in your derivation. Problem 4 solution. The critical Euler buckling load is where I equals 2/3B3H for a slender column AB, so Kc equals 4, critical plate buckling load is where D equals EH3/12, 1V2. Equating two critical loads, this gives us Solidworks assignmenthelp.com. Rearrange the above equation, we have. Finally, Solidworks assignmenthelp.com.